चलो ठीक है, winter 2022, or either we're starting with the first question. ठीक है, ये मैं यहाँ पे भी लिख लूँ. So starting with the first one, this one is about lattice energy, and he says complete the energy cycle involving the enthalpy change of solution. I say enthalpy change of. This one is about enthalpy change of solution. So KCl solid. Now enthalpy change of solution is that KCl solid will turn into KCl aqueous. So K plus 1 aqueous plus Cl minus 1 aqueous. So this is your enthalpy change of delta H solution, right? That's your delta H solution. और क्या होगा इसमें? What's the Hess cycle involving hydration? The first step is that when you want to form aqueous solution, you would first have to break the lattice. So that would be lattice energy. And or either we're starting with, so you're going to break the lattice, it will form K plus 1 gaseous ions and Cl minus 1 gaseous ions. And since we're breaking the lattice, this will be actually the negative of lattice energy, or we can change the direction of the arrow. Because lattice energy is the energy that is released when you're forming a lattice. So this is your lattice energy. And finally, this part, that's your enthalpy change of hydration. Okay, that's delta H hydration of your gaseous ions. So remember, this is your enthalpy of solution cycle. That when you want to dissolve something, you have to break the lattice. That's the first thing. You form gaseous ions, and then those gaseous ions will turn into aqueous ions, and that's your enthalpy change of solution. ठीक है, ये clear है? So then,
yes, sir.
The next thing is use data to calculate the enthalpy change of hydration of magnesium ions. Show your working. So enthalpy change of magnesium ions, hydration is given, solution is given. So we can make a similar cycle, Hess cycle, for MgCl2. So MgCl2 is solid. It will turn into, this is enthalpy change of solution. So it will turn into aqueous ions, dissociated. So you've got 2Cl minus 1 aqueous. So this part is enthalpy delta H solution. And it has a value, that value is given over here in the question. Enthalpy change of solution of MgCl2, that's minus 155. That's already given. That's minus 155. You're going to break the lattice. So that's, it will turn into gaseous ions, Mg plus 2 gaseous, plus 2Cl minus 1 gaseous. So how do you break the lattice? That is lattice energy. So lattice energy, is it given for MgCl2? That is also given. That's minus 2493. And that is for forming the lattice. So if you're breaking the lattice, it's going to be plus 2493. Of finding enthalpy change of hydration. So you want to hydrate magnesium ions, so you don't know what that is. So that is X. That is what you're trying to find out. And the enthalpy change of hydration of Cl ions, that is given or not? Hydration of Cl ions given. That's minus 364. So that's provided. So that's minus 364 2 times, because you got 2 Cl ions. So only Mg ions enthalpy of hydration is not given. So you're going to try and find that out. So one path is equal to the other path. So that means that's your one path. That's your other path. Minus 155 is basically equal to, okay, that's plus 2493 plus X minus 364 times 2. So find out what X is. X is going to be what? It's going to be minus 155 minus 2493 plus 364 times 2. So what are you getting?
minus 1920.
So you're getting minus 1920 kilojoules per mole. Now explain why the lattice energy of MgCl2 is more exothermic than the lattice energy of KCl. So why is MgCl2 more exothermic? What's the reason?
It has a higher charge.
One thing is it's forming a stronger lattice because it's a +2, the K is +1. So greater charge. What's the second reason?
It's a smaller atom as compared to K.
Smaller ion.
Ion, yeah.
Mg that's its electronic configuration is 2,8. K's electronic configuration, K +1 is 288, right? So that's 3 shells. So K is much bigger in size. Bigger ions, they always form weaker lattices. Smaller ions, they form stronger lattices. So you're going to state that Mg has greater charge and it's a smaller ion, so which is why overall it's got a greater charge density or a higher charge density. So इस वजह से ना higher charge density. So that's why it's going to have a stronger lattice. And significantly stronger lattice. Define the following terms: enthalpy change of atomization. What is enthalpy change of atomization? Endo or exo? Okay, the atomization is when you're forming atoms from the elements. It's the energy that is needed. You're breaking bonds. Energy needed to form what?
Endothermic.
It's endothermic. It's the energy that is needed to form 1 mole of gaseous atoms. From what? From its element. And the element has to be in its standard state. So you would always be breaking bonds, which is why it's always going to be endothermic. Electron affinity kya hoti hai? What's electron affinity? And is it endo or exo?
Both.
It could be both because the first one is exo. It becomes harder to gain electrons once you become negatively charged. So the second and third, it becomes endo. So it's the energy released or absorbed when 1 mole of gaseous atoms they gain 1 mole of, so it's exact opposite of ionization energy, gain 1 mole of electrons. This should be one mole. Gain 1 mole of electrons to form 1 mole of gaseous -1 ions. What is meant by entropy? What's the literal definition of entropy?
The measure.
So it's the measure of disorder of a system. Potassium chloride is very soluble in water at 20 centigrade. Explain the solubility of potassium chloride by reference to change in entropy. So it's very soluble at 20 centigrade. I don't know what he means by change in entropy. First thing, what is the change in entropy when potassium chloride dissolves?
It increases.
So it increases, yes. So is it is delta S positive or negative?
It's positive.
So it is positive. So it is positive, and remember, delta S positive is always explain the solubility of potassium chloride by reference to change in entropy. So I don't know what to write in this. I mean, what is he asking exactly? Just 1 second. Let's open the marking scheme for this. This one was delta S is positive, yes. And that's it. Ionic lattice solid forms aqueous. So you just have to describe this. I mean, that's it. So he was just asking this, what we wrote. And he was just asking why is it positive? So it's forming dissociated aqueous ions. So the number of particles increase. So you have more. So what the question meant was, you just have to describe what delta is what is happening to delta S. Now use the Gibbs equation in your answer to predict whether potassium chloride is more soluble in water at 20 or at 80. Explain your answer. First thing, what's the equation for Gibbs free energy? Okay, what's the equation for delta?
Minus T into total entropy.
So it's delta H minus T times delta S, right? Not total entropy, entropy change, okay? And enthalpy change. But total entropy is something else. So it's the change in entropy, temperature multiplied by the change in entropy or change in disorder. Now he said that use the Gibbs equation. First thing, enthalpy of solution. I think enthalpy of solution for potassium chloride is given somewhere. And I think that's given over here. Did he give us the enthalpy of solution of KCl? That's positive, right? That's an endothermic process. So we're going to use that. So that means this is positive. What is delta S? Delta S is also positive. We just figured it out that when you resolve something, the disorder increases. So that is also going to be positive. Now, the first thing, delta G, what value should it have for the reaction to be feasible? A negative or positive?
Negative and high temperature.
Okay, so negative means more feasible, right? So remember, whenever delta G is negative, that means the reaction is going to be feasible. That means overall the system is exothermic. That means that it has enough energy to do all the work itself. It doesn't need any help from outside. Delta G is like the total energy available to the system. So agar wo positive hota, that means it needs energy and it won't, the system will not work until you give it energy. So negative is always feasible. So both of your terms are positive, but because of this negative sign, this term is actually negative. So one of your term is positive and the other term is actually negative. So when you have a higher temperature or a larger T, it's going to be, the negative side will become larger as well, right? So overall, it's going to become more feasible. So this is exactly what you're going to write, that if T increases, what happens is that your T times delta S also increases. And because of that, your delta G becomes more negative. Because T times delta S is actually a negative value. So delta G becomes more negative or lower. And hence it's going to become more spontaneous.
सर एक मार्क के लिए क्या बताना है ये सब?
हाँ, ये सभी बताना होगा. You have to use the Gibbs free. I mean, I'll show the MS as well. So delta G is more negative at higher temperature, or T delta S is more positive at higher temperature. You get a bigger value. Minus T delta S is, I mean, so basically you have to explain the whole thing. I mean, the same thing. They just gave a one-line answer, basically, that if delta G, even that is acceptable for just 1 mark. So you don't have to explain the whole thing, just tell them that. But better to explain the whole thing. Okay, you have enough lines, you can write all of that. As the next one, news first, I didn't see first, just a second. Yep, it's first. So it's the, yep, that's going to be incorrect. Okay, I didn't see first. Okay. Now, the next thing, explain what is meant by the following term. What's a homogeneous catalyst? What's a heterogeneous catalyst? 1 mark each.
Catalyst.
Same phase.
Same phase. You get catalysts and reactants. So catalysts and reactants have exactly the same phase. And the other one is catalysts and reactants have different phases. Now, this specific reaction, you have to remember this reaction. It's a specific example of a homogeneous catalyst, and you have to remember this reaction. You don't have a data booklet anymore, so that's why it's even more important to actually just memorize the reaction. So there's this reaction that is apparently very feasible according to electrode potentials, because it's I2 plus 2 electrons, that's 2I minus 1, and that's 0.54 volts. And you've got another equation which is S2A2 minus plus 2 electrons, 2SO4 minus 2, and that's 2.01 volts. Now, the rule in electrochemistry is that the higher potential gains electrons, gets reduced, and the lower potential likes to lose electrons. And you get this reaction that the I minus 1 loses electrons to form I2. I minus 1 turns into I2. And your S2O8 turns into SO4 minus 2. So you're getting this reaction. And it's a very feasible reaction because the E0 cell is very, very positive. It's reduction potential minus oxidation potential. So it comes out to be 1.47 volts. I mean, the difference is 1.47 volts. The Pella question, why is the reaction, so I'm doing this in detail. So why is the reaction not happening? Why is the reaction slow, even though it's...
Because they both are negatively charged.
The higher E0 cell means, okay, it's very feasible. It's going to be a very fast reaction. But in practical terms, there's no reaction, or wo sahi hai ki it's both of the ions are negatively charged. So, which is why it has a very high activation energy. Although this reaction is very feasible, the electrode potential value E0 cell says that it's going to be a very fast reaction, but it doesn't happen. It's a very slow reaction because both of them are negative. So negative ions, they repel each other, which is why they're going to have very few collisions. So the reaction is going to be very, very slow. So this idea is that they're not going to react with each other. So instead, what they do is these two will have no reaction with each other because both of them will repel each other. So instead, what happens is that you add iron ions as catalyst. Now the two electrodes are not reacting with each other. Now these iron ions are going to be having a potential of 0.77 volts, and they're going to catalyze the reaction. Now, the two reactions, the green ones, they don't react with each other. So iron ions will react with the iodine. So iron ions are the higher potential. So the iron ions are the ones that are going to gain electrons, and the I minus 1 is the one that's going to lose electrons. So your equation, the first equation is going to be that the iron ions, the two Fe3 plus ions, will react with the two I minus 1 ions, and they're going to produce I2, and they're going to produce two Fe2 plus. So Fe3 plus turns into Fe2 plus, I minus 1 turns into I2, right? So that's your equation. That's the first equation. Then the same iron ions will also go and react with SO4 2 minus. That's the higher potential that gains electrons, and the iron ions are the lower potential, so they lose electrons. So the same iron ions, they also go and react with, they react with the sulfates S2O8 equation. So the S2O8 2 minus turns into 2SO4 2 minus. And the iron ions, they 2Fe2 plus, it turns back into 2Fe3 plus. So you've split the reaction into two parts, and you've got both your products now. You're getting iodine, and you're also getting SO4 minus 2. So these were your, हाँ जी.
सर ये हम लोग दूसरी इक्वेशन मतलब इसका ऑर्डर जरूरी है दूसरी equation पहले की जगह
नहीं,
पे
order important नहीं, order it's just two reactions simultaneously happening, so the order is not important. ठीक है, वो separate reactions हो रहे हैं. The iron ions are reacting with I-1, the iron ions are also reacting with the sulfate, so the order is not important. ठीक है, it could have been the other way around. But end goal वही होगा दोनों cases में. It's going to be that the iron ions remain unchanged. You've got Fe3 plus, and at the end of the day, you still have Fe3 plus. So that means the catalyst is not undergoing any change. Is that clear?
Which of the reaction is
Yes,
it
sir.
for the exam?
Dipesh, what's the question?
Like total how many reactions is like very useful for the examination, like this?
See, this one is a specific example that you have to remember. This one. It's a, I mean, because this is specifically quoted in the syllabus, the for homogeneous catalyst. I mean, iron ions are a homogeneous catalyst because they have the same, I mean, they are ions, aqueous ions. The I-1 is also aqueous, H2O is also aqueous, so they're all aqueous ions. So which is why it's a homogeneous catalyst, and you have to remember this specific example. Yeah, I mean, this one specifically. Suggest why the alternative route in the presence of Fe2 plus ion has a lower activation energy. Then the route, so we talked about that. The two ions were negative, so they were not reacting with each other, but now the ions are oppositely charged, which is why they're going to be attracted to each other. They're going to have a lot more collisions in this case. TK, clear?
Yes, sir.
Now the next one is about rate constant, I think. So nitrogen monoxide reacts. The reaction is second order with respect to NO, and first order with respect to oxygen. So under certain conditions, the volume of the rate constant is K. So they've given you K as well. Construct the rate equation. So it's K times NO squared. So the rate depends, and on O2 it's power 1, right? Is this clear?
Yes, sir.
And you just have to figure out the rate equation. So the rate of reaction. So everything is given. So rate is equal to, you calculate on a K is 8.6 times 10 power 6 multiplied by NO concentration is given as 7.2 times 10 power minus 4. And that's squared. And O2 is 1.9 times 10 power minus 3, and that's power 1. So kya, what are we getting?
Sir, ये rate की equation में हम लोग products को नहीं लिखते हैं ना?
नहीं.
8.
हाँ, क्या है?
8.470 into 10 raised to power minus 3.
I said rate equation में products are possible if the rate depends on the products, but usually normally it doesn't depend on the products. Normally it never depends on the products. There are some reactions which are auto-catalyzed reactions, which means the product speeds up the reaction, which is the product acts as a catalyst. So, I mean, 99% of the reaction or 99.99% of the reactions, the product has no role in the rate of the reaction. It's just reactants and the catalyst. If there's a catalyst, you write the catalyst as well. लेकिन ये simple था. He told you everything. He gave you all the information. So you just had to just plug in values. Now the rate equation for this reaction is given. The value of K is also given. The reaction has a constant half-life. Explain why this is the case. Just one mark. So
is it
Zero order
because
है.
it's first order?
First order, right? Because remember, zero order means first order always has. So it's first order with respect to whatever this is. Yes, it's first order with respect to this. And overall, it's a first order reaction. Now, in a first order reaction, it's directly proportional. Rate and your concentration of your reactant is directly proportional. So that means if the concentration decreases, the rate also slows down. So it's going to have this graph that the reactant concentration initially will be very high, and then it's going to slow down, and it's going to have a constant half-life all half-lives will be kind of constant. They'll take the same amount of time. The reaction will slow down eventually. It's directly proportional. Now use the information in the question to show that the half-life of this reaction is 2.77 times 10 power 4 seconds. So how do you figure out the half-life? Anyone, any idea? How do you figure out the half-life in this case?
We'll take the power as x.
Power pata, that's 1. He's saying, how do you measure the half-life? Remember, there's this formula, ठीक है, मैं उसका constant भूल गया. Let me just show you. There's this
Is
extra
it 0.963 divided by 1 over 2
by t half,
times?
right? K is basically,
Yes.
yeah, I just want to figure out the constant 0.9. 1 second, let me just double check this one. 1 second. Sorry, this is the data booklet. I said this question is very important because it comes very infrequently. Like, there's hardly 1 or 2 questions. So this is the half-life, right? So this one, 0.693. You remember your rate constant, and this only applies to a first order reaction. That's it. It doesn't. It's just this formula. That K is 0.693 divided by T half. If you want to figure out K, where's the paper? So 0.693 divided by the half-life. And remember, this formula only applies to a first order reaction, not to a second order reaction, because in the second order reaction, the half-life constantly changes. So you can't apply that formula over there. And even in a zero order reaction, the half-life constantly changes as well. So you can't apply the formula over there. So remember, this thing, I mean, I've hardly seen 1 or 2 questions on this particular formula. So remember, keep this in mind. I mean, it's a very small formula. We know K. So K is 2.5 times 10 power minus 5. And 0.693 is your constant. And you've got T half-life. You can figure out the half-life. So what is the half-life? That's going to be 0.693 divided by 2.5 times 10 power minus 5.
27,700.
Okay, so it's 27,700 seconds. Then you have next part. Okay, but make sure this thing, okay, remember this thing. Even I keep forgetting what the constant is. And make sure don't apply this to a second order or a zero order reaction. This only applies to a graph that has a first order shape. Then you'll be able to figure out the half-life by using the constant K.
Sir, isn't it ln2 over t half? It's not the same.
It's the same.
It's
Yes.
same.
ln2 is, I think, 0.693, right?
Isn't the
सर
same?
नेचुरल लॉग 2 को k से डिवाइड किया हुआ है.
The natural log 2 is I think 0.693, right?
Sir, it's easier to remember.
Okay, a lot of people don't actually know what natural log is, especially the ones who don't do math. Okay. And the next one is 8 into 10 by minus 6 moles of platinum are added to 100 cm3 of water. Calculate the time taken for the concentration to fall to 2.5 times 10 power minus 6. That's a tricky question. And remember, it's constant half-life. So you are at 8 times 10 power minus 6. So how much time would be required for the concentration to decrease to 2.5 times 10 power minus 6? How would you do this? You know the constant, how many half-lives only? How many half-lives do you need?
You need to keep dividing 8.00 times 10 to the power of -6 by 2 till you get 2.5 times 10 to the power of -6.
So basically, it's every half-life, every time there's a half-life, the concentration decreases by half, right? I mean, that's it, right? So for example, the first half-life, after 27,700 seconds, yeah, are you getting this? Asa, you had to show, you're getting the same. Anyways, so basically the way you're going to solve this is, it's 8 times 10 power minus 6. That's the starting concentration. After 27,000 seconds, the concentration will decrease by half. Then after another 27,700 seconds, the concentration will decrease by another half. So it will become 1/4. Then it will again decrease by half. Now you don't know how many times it decreases by half, right? But you know the answer should come out to be, you're expecting after how many half-lives will the concentration end up as 2.5 times 10 power minus 6. Okay, that's what you're trying to solve. So this is the equation that you're trying to solve. So what's the answer to this? You're going to take.
Sir, मैंने try किए second half life पे 2 into 10 raised to power 6 आ रहा है -6 2.5 into 10 raised to power -6 नहीं आ रहा.
So that means it's not a whole number, right? N is not a whole number.
Mhm.
So what is half to the power n? That's equal to what? 2.5 times 10 power minus 6 divided by 8 times 10 power minus 6. So it's going to be 2.5 divided by 8, right? Yeah, okay, that's it. Now the trouble is, now this is a problematic part, because people who don't take math, they'll actually struggle with this. How would you solve how would you solve this? How would you figure out what n is?
ln लेंगे.
ln log, normal log, you can take normal log. Achha, but the people who don't take math, I'll just tell them that if you take log on both sides, log of half, and on the other side, it's log of whatever this is, 2.5 divided by 8, right? Any power that you have, it becomes a coefficient. So it's going to become n log half equals log 2.5 divided by 8. And then you can solve for, it's log 2.5 divided by 8 and divided by log half. What do we get in your calculator?
1.678.
So you're getting 1.67 68 ka lete. So you're getting 1.68 as the answer. So it's not exactly 2 half-lives, right? Because after the first half-life, it's going to drop to 4. After the second half-life, it's going to drop to 2. We want 2.5 times 10 power minus 6. So it's not exactly 2 half-lives, it's actually 1.68 half-lives. Is that clear?
Yes.
Or half-life thi kitni? The half-life we already calculated, that was 27,700 seconds, right? So one half-life is 27,700 seconds. So 1.68 half-lives are 27,700 multiplied by 1.68. So what do you get for this?
4648.25.
46 kitna? 46?
4648.25. 9.
नहीं इतना कम तो नहीं होगा. It's being multiplied by 1.68.
Oh, I missed a 0. Wait.
Sir, 46,482
seconds, right? So that's your answer. Achha, but anyways, for this you had to go into log, because there's no other way to figure out what n is. Okay, first half-life, it's going to decrease to 4. Second half-life, it's going to decrease to 2. It won't decrease to 2.5. So it's half-life. Every half-life, you don't know how many half-lives, so that's n. That's the power. 8 into 10 power minus 6. How many half-lives? You don't know how many half-lives, right? Or how many times it's going to be halved. The answer should be equal to 2.5 times 10 power minus 6. You solved for it. You got this expression, and then you did log. And when you take log, the power becomes the coefficient, and you were able to figure out 1.68. So it came out to be 1.68 half-lives. And if it's 1.68 half-lives, We know that one half-life is 27,700, and that's going to be our answer. And we can, where's the marking scheme for this one? Okay, so it's they're saying it's 5. Why are they saying it's 5 half-lives? Eight into 10⁻⁶ moles at the beginning. Acha, theek hai, nahi, we may, nahi, theek hai. Acha, that's what I was thinking. Why did they go into log? Because people who are taking bio, they wouldn't be able to get log. Acha, we made a mistake at the start. Everything was fine except for one part, which is that 8 into 10⁻⁶ was moles. So you had to find out the concentration in 100 cm3. So 8 into 10⁻⁶ was not the concentration. 2.5 into 10⁻⁶ mole per dm cube, that was the concentration. So we made this mistake. So tell me, how many, what's your initial starting concentration? That's 8 times 10⁻⁶ divided by 0.1 mole per dm cube. So what is it going to be?
-5 हो जाएगा.
Okay, that's going to come out to be -5, right? So that's going to come out to be -5. And then, so it's going to be 2.5 times 10⁻⁶ divided by 8 times 10⁻⁵. What do we get for this?
सर ये -5 कैसे आया?
-7 होगा.
नहीं, 8 times 10⁻⁶ moles in 100 cm3 water, right? So that means 8 times 10⁻⁶ moles in how many dm cube? 0.1 dm cube, right? -7 होगा, -5 होगा?
Sir, -5 आ रहा है.
-5 ही होगा. So it's going to be -5.
0.031 इसका.
नहीं, exact बताओ. 0.03.
Um, 0.03125.
0.03.
125.
Fractions by क्या? What is 0.03125 in fractions? Does the calculator tell you?
Yeah, 1 by 32.
1 by 32. हाँ, ठीक है. 1 by 32 is, so this is actually 1 by 32. ठीक है. Now you don't have to go into log. So it's 1 by 32. So half to the power n, when is half to the power n equal to 1 by 32? N is equal to going, like what power will give you 32? That's going to be 5. Is that clear? हाँ, इसमें फॉर्मूला बताता हूँ, एक्सप्लेन करता हूँ, ठीक है? But is this, अच्छा, ये clear है that you no longer have to go into log? Actually, you never actually had to go into log because a lot of people actually don't do log. अच्छा, anyways, अच्छा, इसका formula, I'll tell you the formula, ठीक है? The formula is, remember this, the formula for calculating half-life, ठीक है? You probably did this in O-levels physics as well, जहाँ पे radioactive decay है, ठीक है? So you've got a starting concentration, right? Let's say any starting concentration. Let's say it's 10 mole per dm cube, right? So if it's a first order reaction, you've got constant half-life. Let's say you've got a half-life of 10 seconds. So after 10 seconds, the concentration will decrease by half. So it will become what? 5 mole per dm cube. Then the reaction continues. You've got a constant half-life. So after another 10 seconds, the concentration decreases by another half. So it's going to become 2.5 mole per dm cube, right? And then so on. After another 10 seconds, it's a first order reaction. It's constant half-life. The concentration will become, what's half of 2.5? That's going to be 1.25 mole per dm cube, right? So this is what's going on. So basically the formula is your starting concentration is 10 mole per dm cube. And every half-life, it's becoming half. If it's the first half-life, it becomes half once, right? If it's the second half-life, then it's going to be, second half-life will be that it's going to become 2.5. So it's going to be half to the power 2, right? Third half-life, it's becoming half 3 times, right? So it's going to be half to the power 3, ठीक है? तो हारिस ये बात clear है कि what's happening to the half-life? So if you don't know how many half-lives you've got, so that's n. And whatever happens, like if it's 1.25, so you can figure out how many half-life that's it. So it's going to be 1.25. So you're going to try and calculate this. So the 10 is going to be taken to the other side. So it's going to be half to the power n, and that's equal to 1.25 divided by 10. I'm going to try and write that as 1 over 10 divided by 1.25. What do I get? I get, kitna aega? 1 over 8. Okay, so that means n is equal to 3. That's 3 half-lives. Is that clear?
Sir, 1.8 आपने कैसे लिखा है?
वो था ना कि मैंने उसको उस fraction को ना, I tried to write it in the same form. So the top was 1, so I divided the top by 1.25. I also divided the bottom by 1.25, right? So the numerator became 1, the denominator became 8. Is that clear?
Okay, yeah.
Or agar phir bhi confusion है, the best way is to go into log. ठीक है, half n, and that's 1.25. They don't want you to go into log, ठीक है, but you can still go into log and solve this. So the best way is the easy way is just take log. So it's going to be log of half equals log of 1.25 divided by 10. And n would be, divide this by log half. And you will find what n is. Okay. Say this one. And mark this question. It's a slightly different question because it involves the k part as well. So it's important to actually mark this question. This is W22 question paper 4.3. Keep this question in mind. Now here's the next question. It's
Sir, उसका final answer क्या था ऊपर वाले का?
ये वाला?
Yes.
The n, this was all wrong because we didn't take concentration. N came out to be 5, right? So 5 times the half-life, 27,700 seconds. Okay, is this clear?
सर
हाँ जी.
सर जो आपने फॉर्मूला लिखा तो वो आप शो कर सकते हैं?
इस फॉर्मूले का मैं उसको बना देता हूँ. वैसे तो फॉर्मूला starting concentration ठीक है, it multiplied by half to the power n, and the concentration you're looking for the final concentration.
ठीक है.
So this only works for first half-life.
हाँ, क्योंकि it won't work for 0 order or for second order because it only works for first order. जहाँ पे it's constant half-life, because in the other ones the half-lives are always changing. Second order में the half-life is doubling. The problem is the formula will not work because every time the half-life is not going to be constant. ठीक है? Or 0 order maybe the half-life is changing, so it's not going to work for that as well. Only for constant half-life. ये दोनों चीजें ना, both of these. The first formula, this one, k is equal to 0.693 divided by t half, that only works for first order. Okay. And this formula also works only for first order. Because when masla yoga 27,700 keeps changing. Because in a second order reaction, the half-life doubles. The second half-life is double the first one. The third half-life is 4 times the previous one. What the half-life we change? So this is not fixed in second and 0 order reactions. So only for first order. Okay, is this clear?
Yes, sir.
So this one, describe the standard conditions used in, so what are the standard conditions used in a half cell?
1 mole per dm cube.
25 degrees Celsius.
You get 298 kelvins, and I mean the pressure is not
1
relevant.
atmosphere.
The pressure is not really relevant over here because pressure is for gases. There is no gas. But no issues with that. Completed diagram to show how the SN4 plus SN2 plus can be measured experimentally. How would you measure the electrode? So how does the SN4 plus SN2 plus electrode look like? As I said. So how would it look like?
PT. Platinum use hoga.
Okay, so you're going to use a platinum electrode. Your both ions will be part of the solution. So it's going to be SN2 plus aqueous. And it will also have SN4 plus aqueous as well. But I'll write this properly. And both of them will be 1 mole per dm cube. And what's in the other container?
Hydrogen.
Okay, that's going to be your hydrogen electrode. So it's going to have H2 gas. That will also have a platinum electrode. There's going to be H plus 1 aqueous, and that's going to be 1 mole per dm cube. You're going to connect them together with a voltmeter. And there's one thing that's missing, and that's
Salt bridge.
सर अगर सॉलिड भी हमारे हो एक्सपेरिमेंट में तो हम लोग उसका भी 1 मोल पर डीएम क्यूब लिखेंगे.
ये solid का तो 1 mole नहीं होता. मतलब constant mole per dm cube only applies to concentration solutions. So not for solids. As equal volumes of 1 mole per dm cube SN2 plus 1 mole per dm cube C lines are mixed. Use relevant E0 values to explain whether the reaction occurs between these two ions. So will there be a reaction between these two ions? SN2 plus, यहाँ पे, SN2 plus is over here, and Cl minus 1. So the question is here, Cl minus 1 and SN2 plus. So the question is, will there be a reaction? So tell me, will there be a reaction or will there not be a reaction?
Sir, plus 0.15 वाला SN use करेंगे ना हम?
What's the rule? The higher potential gains electrons and the lower potential
loses.
So who's the highest potential in all the three reactions? The three
1.36.
So that's the highest, right? So that means it would always be gaining electrons, right? Because it's a very high potential. Now, so it has already gained electrons, so nothing will happen because we already have Cl minus 1 ions. Cl minus 1 ions will not react because they're not willing to lose electrons because they are the highest potential. They'll always like to gain electrons, so they're not going to lose electrons. So the point is there will absolutely be no reaction. Is that clear?
Yes, sir.
Because they've already gained electrons, and so they're not willing to lose electrons. So the point is, it's not, but technically, how would you explain this? The way you're going to explain this is, if Cl minus 1 were to react, so there's only one possible way. Actually, is there the Cl minus 1 in other reactions as well, by the way? But that they have, I mean, I won't use this reaction because it has OH ions as well. He didn't talk about OH ions, so I'm not going to write this reaction. So there's Cl minus 1 only in this one. So if Cl minus 1 were to react, there was only one option, that it would lose electrons, and that it will, I mean, that's the only option, right? That's the only way it's capable of reacting, right? That the Cl minus 1 loses electrons.
Sir.
So that means the SN2 plus would be the one that would be gaining electrons, right? But that's not going to happen because the electrons are gained by the higher potential and the electrons are lost by the lower potential, which is not true in this case. So if by force I do this reaction, the E0 cell is what? The E0 cell is reduction potential minus the oxidation potential. So what do I get? What is my reduction potential? The gains electrons, that's minus 0.14. What is my oxidation potential? The part that loses electrons, that's 1.36. So it's minus 1.36. So I'm getting a very negative E0 cell. And a very negative E0 cell is going to tell me that this reaction will not happen. Or it will happen in the opposite direction. It won't happen in this direction. The Cl-1 will not lose electrons because you're getting a very negative potential. That basically indicates that you're doing everything the wrong way. Is this clear?
Yes, sir.
So how much? Let's complete this question just quickly. So that's what you're going to write. It's no reaction. And that's why he's talking about the E0 values. So you're going to state that the E0 cell comes out to be minus 1.50 volts. It's negative, so not feasible, not spontaneous. Let me just check how they've described this one. No reaction. The E cell is minus 1.5 volts. Yeah, that's exactly how they wrote this. The next one is equal volumes of SN2 plus and VO2 plus are mixed. Write an equation for the reaction that takes place in the resulting mixture. So now it's VO2 plus and SN2 plus. So go back here. Let me get rid of all of this. Now VO2 plus and SN2 plus. So I've got VO2 plus over here, and I've got SN2 plus in two equations. Now, VO2 plus is the higher potential, right? So it's 0.34. It's the out of the three, it's the higher potential. It's the one that's going to gain electrons, right? So that's fine. So there's nothing wrong with that. So that's the higher potential, right? So who's going to lose electrons? The one that has the lowest potential. So I can't do this one because SN2 plus has already lost electrons. So it's probably going to be this one. SN2 plus would lose electrons. So we've got a reaction now. VO2 plus gaining electrons and SN2 plus losing electrons, right? Okay, lowest ढूंढना, so that is the lowest. Okay, that's fine, that's the lowest. But it's SN2 plus will not be losing electrons in that case. We want a reaction with SN2 plus. Agar मैं पिछला use करता ना, then it would have been SN that would be losing electrons. He didn't ask us to write a reaction with SN. Do you get the point?
Yes.
So basically, I have to go with the things that I have. So that's why I did not use that one. So anyways, that's the reaction. You can make the equation. What's the equation? It's going to be the reactant is SN2 plus. The other reactant is VO2 plus, but I'm going to multiply it by 2. Okay, I need to make the number of electrons gained and lost equal. Okay, there are 2 electrons being lost, 1 electron being gained. VO2 plus will have 4 H plus 1 ions. And then what are your products? In the first one, the product is going to be SN4 plus. And the next one, the product is going to be V3, 2V3 plus 2H2O. Okay, so these 2 equations are added up. Is this clear?
Could you explain once again, like why didn't we take SN2 plus?
Okay, so in detail. So we've got, now remember the rule is, let me get rid of this as well. Now remember the rule is, first thing is mark all the reactants. So he was asking for, so these are the steps. So he was asking for a reaction between SN2 plus and VO2 plus, right? So I went and I marked wherever I saw SN2 plus. And I saw VO2 plus over here. And I also saw VO2 plus over here as well, by the way. In this one as well. So there were 4 equations which had SN2 plus as well as VO2 plus. Something was happening to SN2 plus and something was happening to VO2 plus, right? Now, the next thing is you're going to look for the highest potential. The highest potential gains electrons. Now, which one out of the four do you think, these four, which one is the highest potential? It's the last one, right? I mean, is that clear? That's the highest potential, right?
Yes.
So that's the one that gains electrons. But I can't take that one because it's something else that's gaining electrons. We want VO2 plus something to happen to VO2 plus. We don't have all of that. So which is why I want something to be happening to the reactants that I have, not happening to something that I don't have. And if I choose this equation, it's VO2 plus that's gaining electrons. I don't have VO2 plus. Is that clear? So I can't use this equation. Is that clear?
Yes.
So I'm going to reject that. I'm going to cut that out. So the three remaining reactions, which one is the highest potential? It's 0.34, right? So that means it gains electrons, right? And that's fine because it's the thing that I have that is gaining electrons, which is why there's nothing wrong with this. This is perfectly all right, and it gains electrons, right? So this is the one that's gaining electrons. Is that clear? Then I'm going to do the reverse. I'm going to try and find out who loses electrons, the one that has the lowest potential. The lowest potential is which one? Minus 0.14. So that is the one that loses electrons. Now, again, I have a problem because the thing that's losing electrons, I don't have that thing. Well, I have Sn2 plus. I don't have Sn losing electrons. So this does not apply to the things I have. Well, I don't even have Sn, so how can it lose electrons? Is that clear?
Yes, sir.
So I'm going to reject this equation because this does not apply to my reaction. So out of the remaining equation, which is the lowest potential, is this one, right? So that means that's fine, Sn2 plus. I do have Sn2 plus that's losing electrons. So the steps are mark all the equations, the ones where you have your reactants. Then you try to figure out the highest one that gains electrons. But there's one condition, and that one condition is that it has to be one of the two things over here that gains electrons. It can't be something else. Is that clear? And then you find out who loses electrons. The lowest one is the one that loses electrons. So you just can't take any potential which has a low value. It has to be one of these two. It has to be one of these two that loses electrons. So is that clear why I rejected Sn? Is that clear?
Yes, sir.
Although Sn was the lowest one, but I did not have Sn. I did not have Sn in my reactants, right? TK, is this clear?
Yes, sir.
So remember this method, TK, remember this method. 2 steps. Go to the website or the channel. There would be detailed explanations of this, how to make equations. So I think I just have another class, so we'll just discontinue over here. TK, this is the third question for, and make sure you mark that question on reaction kinetics. TK, that was an important. That's different from the other ones. Plus, it's the latest paper as well, so you're probably going to get something that's very similar to this. Okay, everyone.
Allah Hafiz, sir.
Allah Hafiz.
Allah Hafiz.